Thank you, sir.
Now, last class, what we did, let's have a recap. Last class, uh, I don't know you watched or not. Can you confirm me you watched it or not?
I watched it, but not really in that way. I just skipped the video and like surface.
Okay, so it will help you. Okay, for not only practical, for your overall physics syllabus, I gave you some ideas uh, for our A syllabus, 11 syllabus. You'll get some idea over there. Then later on, I gave you idea about practical and how the practical papers are made and how many questions are there, and in each of the questions how they are assessing you. All this breakdown last class we discussed. Now we will discuss after that. Whatever we discussed that day, we will continue from there. Okay. Just I gave you a review, right? So that you can again try to watch it and get all the things I discussed before. Okay, Amina?
Ji, sir.
Okay, now we are sharing the screen. You see, here we have, first we have the syllabus. Here is the syllabus. Yeah, now uh, we discussed first from the syllabus. If you have the syllabus, you can also check it. Do you have the syllabus? Your
No, sir.
physics syllabus, you should have it for all the subjects. It's free in Cambridge website. If you search in Google, you
Yes,
will
sir.
get these resources available free for all. Okay, you should have some idea from the syllabus for all subjects. Right now, look, we are discussing um, about the uh, recording of data, observations, and calculations. Till that much we are done in last class. Okay, and now we will
Yes, sir.
continue with the graph. In question 1, there are 2 questions in practical paper. Okay, in question 1, you have to draw the graph from the recorded data of the experiment. You have to draw the graph, and how to draw the graph. There are some instructions from Cambridge. Okay, can you
So this
please?
is same as O level, right?
This is quite similar, but not exactly. These are more, in O levels we are more generous, right? But in A level, as practical, they are a bit more strict about your skill. Okay, so that's why here we should, and there also they, when we will discuss from one of the past paper questions and the mark scheme, then you will understand how it is more more sophisticated and they require more skill from you. Do you understand, Amina?
Ji,
Hello.
sir.
Okay, now
Yes, sir.
can you please read out this from the graph?
Yes,
Yeah,
sir. Plot
please.
the independent. Hello.
Yeah, please read the points.
Plot the independent variable on the x-axis and dependent variable on the y-axis, except where the variables are conventionally plotted the other way around.
Okay, wait.
Clearly labeled.
For every point, we have some discussions. Okay.
Okay, sir.
So this one, independent variable and dependent variable, how you will understand it or how you'll identify it? Can you tell me?
Sir, it would be really nice if you explain it.
Okay, fine. Thank you. So think of that you are asked to find, or you are asked to plot um distance time graph. Okay.
Yes, sir.
So here we got two variables. One is distance, another one is time. And I gave you this example in class also in O levels, that during uh, comparing these two variables, you have to link with real life. Like you are sitting in one place. You are sitting in one place. You are not moving from there. So according to the idea of physics, you have no distance moved, right?
Yes,
Amena?
sir.
Yeah,
Ji,
but
sir.
if you look at your watch at the same time, you will see that your watch is giving the count, right?
Yeah,
It's going.
measuring
So
some time.
the watch is not caring that you are sitting or you are moving. It's doing its work, right? The time
Yes,
will go. Uh, you are standing or you are walking or you are running, whatever. The time will go, isn't it? So that time
yes,
does
sir.
not depend on the distance, but the distance depends on time. So which
Yes,
one
sir.
is independent here?
Time is independent
Okay, so time is independent, and you have to plot it along the
on the
x-axis,
x-axis,
and the distance you should plot
the y-axis.
y-axis. Clear now?
Yes, sir.
Now another example. I'll give you another example, that is extension load graph. Can you remember that one? That is Hooke's law
Yes, sir.
from deformation. So here, can you tell me which one is dependent, which one is independent?
Extension is independent.
Extension is independent or load is independent? Because extension is varying, right? Depending on the loads. If you increase the load,
The extension will also
yeah.
increase.
If you keep the load constant, then there will be no extension, right?
Yes,
Isn't
sir.
it? So
Yes, sir.
extension depends on
On the
load.
load.
So which one is independent?
Load is independent.
Clear now from these two examples?
Yes, sir.
Okay, so they are again saying another one, that exception. They are also saying the exception. Sometimes maybe you got some graph in your past paper question. There you got load extension, right? Isn't it? So they are
Yes,
saying
sir.
about this, that except where the variables are conventionally plotted the other way around. That means in some questions it might be given opposite way, right? That is different, but in practice or in physical appearance, we understand that extension is depending on load.
Load.
So I think from this point you got some benefits, right, from this discussion. Hello, Amina.
Yes, sir.
From this
Yes, sir.
discussion, do you think you got some benefits?
Obviously, sir.
Okay, then continue next.
Clearly label graph access with both the quantity and the unit, following accepted scientific conventions.
Okay, wait. So look here, in O level, always I reminded you about this, right? Like you
Yes, sir.
are you are
Quantity and
writing
unit.
the quantity, but you are forgetting the unit, right? So
Yes, sir.
for this one only for writing the quantity and unit, you have 1 marks. Okay, there are 4 marks in plotting graph. So one of the mark is for writing the quantity and unit. Okay, of course you should write them in correct order. Like if you are writing the quantity and unit, uh, the x-axis one you are writing in y-axis, or y-axis one you are writing in x-axis, then you will not get marks. Clear? Hello?
Yes, sir.
Okay, then continue this. Next one, continue, Amina.
Yes, sir. Choose scales for graph axis such that data point occupy at least half of the graph grid in both x and y direction.
So can you remember? Always I was saying you this.
Yes, sir.
Uh, so this one, you see here, choose scales. That means for graph X is such that the data points occupy at least half of the graph grid in both X and Y direction. That means you, when you are taking
Assalamu
the,
alaikum, sir.
hello, um,
Assalamu alaikum, sir.
walaikum salam, Ahsan,
Yes, sir.
you joined with your brother's ID.
Sir, I'm changing.
Yeah, change it please. Then look, uh, this one, what we are getting in the table, right? For example, you are getting uh, the plottings of distance and time, right? For example, and distance you are getting from 10 meter to 40 meter. Okay, hello, are you getting me, Amina?
Yes, sir. I'm
Okay,
listening.
10 to 40 meter. Okay, so how much you got here? The difference 30, right? Isn't it, Amina?
Yes, sir.
And the time maybe you are getting from maybe from 2 seconds to 8 seconds. Clear?
Yes,
Yes,
sir.
sir.
So this one you are getting the range 6. The time one you are getting the range 6, and
6.
the distance one you are getting the reading how much? The range 3.
33.
30. That
3.
means 30. Yeah. So that 30 and here you got 6. You have to take the range in your x-axis and y-axis in a way so that it covers more than half of the grid. Clear?
Yes.
So
Yes, sir.
when we will get some questions, past paper questions, that time you will
Yes, sir.
get more ideas. Already in O level you got this idea, and now we'll repeat it. Okay, we'll get more explanation of this, more application of this. Then next, Amina, continue.
Use a false origin where appropriate.
Yeah, this one is very important. That always students want to. What I found at the beginning when we started the graph, then I found that you always want to start from the zero, right? Origin
0. Yes.
zero
Yes,
zero.
sir.
But
Yes, sir.
if you are doing this, what happens that this point is not satisfied that time, isn't it?
At
When
times. Yes,
when
sir.
you are going to start from 0 0 and you are starting from 0 0, then 1 2 3, that your graph is coming in a way that it's coming to a corner, a small place. It's not covering more than half of the grid, isn't it?
Yes.
Sometimes your reading is starting from 50, sometimes your reading is starting from 70. That time, if you are taking from 0, that might happen that your graph is becoming very small when you are plotting the points. For
They
that
get more
reason,
thicker.
yeah, for that reason, we need this false origin. Okay, so we will start from other than 0, that is called false origin. Okay, and in your graph it's better to mention it. If you don't mention, it's not a problem, but if you mention, it's better. That if you're writing, if you are using false origin, you should write f dot o dot, that means false origin. Clear?
Yes.
Yes, sir.
Okay, so continue please. Next one, Amina.
Choose scales for the graph axis that allow the graph to be read easily, such as 1, 2, or 5 unit to a 2 centimeter square.
Okay, so this one you understand?
Yes, sir. It's scaling.
That means if you are plotting the graph, that means plotting the points. They are saying that 2 centimeter square. You know, 2 centimeter square. 1 to 5 units. That means when you are plotting the graph or plotting the points, those should be very clear. What happens if you are following this rule? Then it comes automatically. This one can be coming automatically, but if you are following this one, that you are starting from the origin, that time it happens that your readings are coming very clumsy, right? Very small, they are very closest. That time it's very difficult to find the points or the readings clearly from the plottings. That the table you got, from the table you are plotting, but in between 2 points you are not getting very much difference. That time it will not be clear that where which point is staying correctly or specifically. Okay, that will make a problem to plot the straight line, and it will not be giving a good gradient. Then next, continue.
Place regularly spaced numerical labels along the whole of each axis.
Yeah, so this one is saying another point. I think
If you use
you
whole
you
numbers
do
like
it.
one,
You
two,
you
three,
always do it. You don't make mistakes over there. Like for uh, 10 to 20, you are taking one big square. Again for 20 to 30, you are taking two big squares. This shouldn't be happen, right? Always you should follow same same order or same criteria for the whole axis. Got it?
yes, sir.
Okay, then we are going to next page, that is plotting of points. You see here, plotting of points. Asan, hello Asan is there?
Sir,
Asan.
he's speaking, but we can't hear him.
Okay, so what to do then? Will go to you again. Then continue this. No problem.
No
Plotting of
problem, sir.
points. Yeah.
Candidates should be able to
Yes,
plot
sir.
all their data.
Sir.
Okay, Asan. Next one you have to read. Okay. You be aware. Okay. Be ready. Amina, continue.
Sir.
Okay. Candidates should be able to plot all their data points on their graph grid to an accuracy of better than 1 millimeter.
So this is very crucial, right? You have to plot all the points very accurately. Okay. Like sometimes it happens that we are not plotting the points exactly the same
Get the
place
point and
where it
mark.
should be, right? It's like maybe it is a little bit far away from the exact point. So they gave a limit here. They gave a limit here that your point shouldn't be, go away more than 1 millimeter. Okay, clear to you? Hello.
Yes,
Sir.
sir.
So
Yes,
it
Yes,
sir.
is
sir.
very important when, so this thing in O levels we are not, we are not giving so much, uh, strict condition for the candidates, but in AS this is very strict. Okay, and you should follow it. Then continue.
I will continue.
Yeah, Asan, continue. Trend line.
Candidates should be able to identify when the trend of a graph is linear or curved.
Okay, here we may get straight line graph or we can get curved line graph. Clear? It
Yes, sir.
Yes.
depends. It depends
It
on
depends on the
the,
graph plotting.
uh, you have some theoretical knowledge. You have some theoretical knowledge. If you uh, think of the pressure volume graph, okay, and if you think of distance time graph, if they are saying distance time graph, there is constant speed. Hello.
Hello, sir. I'm
Yeah,
listening.
if I'm making it more simpler. I'm giving you example of distance time graph only. So if they are saying you in your experiment, they are saying you to plot a graph where the speed is constant. Speed is constant. Then
Constant.
what? Uh, then what will be the shape of graph if it is constant speed? Can you remember that one?
Constant. The graph will be, sir, কি বলবো? When it's straight. When
Yeah,
horizontally straight.
straight line. If it is distance time graph, this will be a steeper straight line. That means there will be positive gradient, right?
Yes, sir.
Am I right?
Yes,
Yeah,
sir.
look,
Yes, sir.
if it is constant speed, this is distance time graph, right? Distance time
Yeah.
graph. If it is constant speed, then it will be like this straight line. Okay,
Yes.
and if it is constant acceleration, it's not constant speed. If there is acceleration, that means speed increases, right? Speed is not
Yes.
constant. That time, what will be the shape of the graph? Do you know?
Sir, sir, it will be,
Curved line.
yes.
It will be a curved line with positive gradient. Look, I'm drawing the graph. This way, right? This is
Yes.
the I'm writing also text writing. Then you'll understand it. Here, one box I'm writing. Um, here, the first one is cons, constant
Constant.
speed. Okay, the first one is constant speed, right? Isn't
Yes.
it? And
Yes.
the second one is constant acceleration. I'm writing again constant, so that
Acceleration.
as you are getting the recording, afterwards you can also recall. And they who are not attending, if they want, they can also get this. Okay. So this one is, constant acceleration, right?
Increasing velocity.
Yeah, yeah. I'm writing again, no problem. Constant acceleration. Okay. So this one is clear to you, right?
Yes, sir.
Now
Yes,
you
sir.
can understand it from this discussion. What the point is saying you from the trend, right? Trend. So from your theoretical knowledge, you can understand that the graph will be linear or curved. Okay. So the table you got with that when you are plotting on the graph paper, from your theoretical knowledge, you can understand the graph will be linear or curved. According to that, you should draw a straight line or curved line. Okay. In most of the cases, in most of the cases, that means in 95% cases, they tell you that draw best fit of straight line or draw best fit of curved line as you got in O levels, right?
Yep.
Hello. In O levels is
Sir, listening.
clear, yeah, they clearly mentioned it that draw a straight line or draw curved line. Clear to you?
Yes,
So
clear.
don't worry about this, but as sometimes it comes in your mind why I am writing straight line, why I am drawing straight line, why I have to draw curved line. You should be confident what is the origin of it, right? That's why I explained you this one, that how the idea of curved line is coming and how the idea of straight line is coming. So now you are confident, right? You understand it, why they are not always giving you straight line or why they are not always giving you curved line. Now you are clear about this?
Yes, sir.
Hello, Amina?
Sir, listening.
Ji,
Amina?
sir.
Yeah, now how you are feeling now after knowing this? How do you feel now? Before
Confident.
before today, did you know this, that why the shape of the graph is coming like straight or curved?
Yeah, I knew it.
Yeah. So now it's clear to you more, right?
Yes, sir.
Now continue here. Hassan, continue this.
Sir, draw straight lines of best fit curves to show the trend of a graph.
Yeah. So this one is done. Next.
Yes, sir. Draw tangents to curve trend lines.
Okay. So if you are getting straight line, then you can easily get the gradient, right? From the y and x-axis ratio, isn't it? Hello.
Yes, sir.
But if
Yes,
you are getting the curved
sir.
line,
Yes.
you cannot get the gradient so easily directly from there. What you have to do, you have to draw one tangent.
A tangent.
Yeah. If you get the tangent, that tangent is giving you one straight line, isn't it?
Yes.
And that tangent, when you are getting the straight line, and you it's easier for you to get the gradient, right? From the straight line of the curve or tangent, that one is giving you y and x-axis ratio easily, isn't it? That's your gradient. So what is the purpose of the tangent?
The
Can you tell
for the
me?
gradient.
To get the
Yes, sir.
gradient in
Yes.
in your graph, you have to get the gradient. So if it is curved line other than tangent, you cannot get the gradient. That's why we are drawing the tangent of the curved lines. Clear now?
Yes, sir.
Okay, great. Then next, very important thing, you see interpretation of the graph. Yeah, Amina, you continue this interpretation of graph.
Candidates should be able to relate straight line graph to equation of the form y is equals to mx plus c and derive expressions that equals to the gradient and or the y-intercept of the graph.
Okay, so whatever we are getting, relate straight line graphs to equations of the form y equals mx plus c. So this straight line graph or straight line equation, uh, you understand all these things, right? What is y, what is m, what is x, and what is c? Do you understand all of them?
Yes, sir.
So uh, which one is what? Y,
M is the gradient.
yeah, m is the gradient, y is the variable, right? Any value in y-axis, and x is the same points, x coordinate, right? X coordinate value, right?
And it's
For
yes,
every single point, you have x coordinate and y coordinate, right? Isn't it? Hello, hello, are you listening?
yes,
Yes, sir.
yes,
So
sir.
for each of the points, you are getting x coordinate and y coordinate value. That one is giving you y or x, right? And m
Yes.
is the gradient. What is c?
Y-intercept.
What
Y-intercept.
does what does it mean?
C
Y-intercept?
constant. Sir, C is constant.
Yeah, y-intercept means what?
That cross the y-axis or meet the y-axis.
Yeah, y-intercept means the point where the straight line is cutting or crossing the y-axis. Is it clear to you now?
Yes.
Can you tell anyone, please repeat what I told you? What is y-intercept? Anyone, please?
The y-intercept is a point where the line crosses y-axis.
Yeah, the line means the straight
Y-axis
line
crosses
crosses
the
or cut
y-axis.
the y-axis. Okay, that is y-intercept.
Yes.
So if you uh, in your graph, you can if your straight line is crossing the y-axis, you can get it directly from the graph. Okay, and if it is not available there, then you can calculate it from the equation. Okay, you put the value of y and corresponding x, then put the value of gradient, then you will get the y-intercept value from this equation, right? That means c equals y minus mx. From this equation, you can get the y-intercept. There are two ways. Then continue, Amina.
Read the coordinate of points on the trend line of a graph.
Okay, this one is easier for you. Continue. Yeah.
Determine the gradient of a straight line graph or of a tangent to a
Yeah,
curve.
this one you also know, right? How to get the gradient, y by x, right?
Yes,
Then
sir.
next one.
Determine the y-intercept of a straight line graph or of a tangent to a curve, including where these are on graph with a false origin.
Yeah. So this one, I have to include one thing about about the calculation of gradient. Though it's not mentioned here, but it's also one of the criteria in mark scheme. It's available. You will see that over there. That when you are calculating the gradient, you must have to take more than half of the straight line range. Okay, you have to choose
Yes.
choose 2 points in a way on the line. not outside of the line. When you are plotting the straight line, there is possibility that some of the points or some of the readings you recorded in the table, those are not going through the straight line, right?
Yes.
Yes, sir.
Those points you cannot take. You have to take 2 points on the line.
Which
Any
are more
two
than
points,
50%.
any 2 points you have to take on the line, and the range of these 2 points should be more than half of the straight line. Okay, clear to you now?
Yes,
Hello?
sir.
Yes.
Yes,
Yes,
So
sir.
sir.
if it is clear, then you are done with this part. We are going to now next one. Yeah. Drawing conclusions. Can you read, anyone? Yeah.
Yes, sir.
Yeah.
Draw
Yes,
conclusions
sir.
from
Yes,
an
sir.
experiment, including determining the values of constants, considering whether experimental data supports a given hypothesis, and making predictions.
Okay. So here you have to conclude, right? Uh, you got already, here y-intercept is a constant, right?
Yes, sir.
And gradient for a graph, gradient is also a constant, isn't it, for a specific graph? So they they will give you some, points, or in the question paper they will give you some steps where you have to write the value of gradient with unit, and where you have to also write the value of y-intercept, right? So from this graph, from these calculations, you have to write them in those places. This is called drawing conclusions.
And
Okay,
conclusions. Yep.
and later on, estimating uncertainties. Continue. Asan, continue.
Estimate estimate quant estimate quantitatively the certainly in their measurements.
Hmm. So here we got 1 point, quantitatively. Do you understand what
Yes,
is called
quantitative.
quantitative and quantitative?
Hello.
Hello?
Hello.
Yes.
Hello.
Yes, yes. Are you seeing the
Hello.
screen? Are you seeing the
Yes, sir.
Hello.
screen?
Yes, sir, we can.
Yeah. So, Asan, Asan,
Hello, sir.
yes. Are you
Hello.
listening to us? Are you hearing us?
Yes, sir.
Okay, continue. This one, right?
Determine this.
Yeah, look,
Will I continue?
qualitatively. Wait. Qualitatively. What does it
Quantitatively.
mean?
The amount of quantity in it.
Yeah, quantitatively and qualitatively. You have any idea about that one?
The quality.
Yeah.
I don't have the idea of
Okay.
this
Look,
quantity.
this one is written quantitatively. Okay.
Yes.
And in some of the places you will get qualitatively. So when you are getting quantitatively, that means the values you are getting in numerically. Okay. And qualitatively means you will give the explanation from the physical appearance. That one is called qualitative. Okay. Hello.
Hello, sir.
Yeah. So I'm giving you one example to make the difference. I think still you are not clear that what is the difference of quantitative and qualitative. Like you got one straight line and one curved line, right? Isn't it? Hello. In
Yes.
distance time, you got one straight line and you got one curved line. These are like qualitative explanation that in distance time graph, if we are getting constant speed, this line should be a straight line. Okay.
The
And
shape of the group.
Yeah, just from the physical appearance, you are explaining one thing that is called qualitative. But if you are getting some measurements like gradient, for one graph you are measuring the gradient, you are getting the you know uh, values of y-intercept. Those are quantitative values. Clear? Hello?
Yes.
Yes, sir.
Okay, so they are saying about uncertainty. Do you know what is called uncertainty? Anyone? Hello? Uncertainty idea? Hello?
Hello.
Yes.
Yes, sir, we can listen to you.
Yeah, what is uncertainty? Do you understand what
Which
is
is not predictable.
Not predictable.
not predictable? Okay. So you got one topic in your AS syllabus, that is measurement techniques. Can you remember last class I pointed that one, that second
Yes,
topic,
sir.
measurement
Second topic
techniques.
of this.
There you will get the discussion about uncertainty. Uncertainty means the possibility of having errors. Simply you think of this way, that you might have some errors in your experiment, right? Always it will
Yes.
not be accurate during measuring the length or during measuring the time. That's making some human errors, right? Isn't it? So those
Yes,
are
sir.
Yes.
those are uh, there is making some possibilities to have some uncertainties in the value you are recording or the value you are writing. Maybe there is some gap, right, from the accurate value. That is called uncertainty. Okay. For example, when you are measuring time, you are measuring three times and taking the average, right?
Yeah, the mean value.
Maybe even in your average there are some gap from the accurate value. That's your uncertainty. If your accuracy of the uh, for example, your time you measured for a pendulum, it is uh, for a complete oscillation, it is 2.5 seconds, right? Are you getting me? Hello?
Yes, sir.
Yes, I'm
uh,
getting.
you are getting 2.5 seconds and you are recording 2.5 seconds, but your reading, uh, what is the smallest reading, or what is the accuracy of the reading? It is zero point 0.1, right? You are measuring 2.5, that means you are measuring till 0.1 second, right?
Yes.
Hello?
Sir, listening.
Yeah. And whenever you are measuring the length in the ruler, you are measuring till 0.1 centimeter in accuracy, right? Hello?
Yes, sir.
Sir,
So when you will get the theoretical knowledge of measurement techniques, you will get it more, clear explanation of that. However, I am giving you some examples here, like time one, uncertainty in time. I told you you measured 2.5 second, right? Isn't it? So
Yes, sir.
your accuracy of the stopwatch is 0.1 second. So you have to divide it. 0.1 divided by the measured value, then multiplied by 100. 100%. Whatever the value you are getting, this is giving you uncertainty, right? In that measurements. Can you calculate it? What is the reading coming here? Can you calculate it? Tell me.
4. 4.
4. It's coming 4, right? 4%. So the uncertainty in your reading is 4%. Clear now how to calculate the uncertainty?
Yes, sir.
So this way we are calculating the uncertainty in our measurements. Similarly, we are measuring this uncertainty is for in time. In length also we get the uncertainty this way. Okay, done. This part is done. Then uncertainty you have to determine in the final result. We have to write it. There will be one place you have to write the uncertainty. Okay, in especially question number 2, experiment 2, you have one place where you have to calculate this uncertainty. Now continue. Who was reading? Continue the next one.
Express the uncertainty in a measurement as an absolute, fractional, or percentage uncertainty and translate between these forms.
Okay, so they gave here three things. One is absolute uncertainty, another one is fractional uncertainty, and other one is percentage uncertainty, right? So
Yes.
here you got this one. This is giving you fractional uncertainty. This one is giving you what?
Percentage uncertainty.
Percentage.
Percentage uncertainty. And sometimes they will tell you what is the, like this one here 0.1, it is your absolute uncertainty, right, for this measurement. And sometimes they will tell you what is the absolute uncertainty. They will give you one measured value, and they will also give you absolute uncertainty in that measured value. That time you have to calculate this way. Clear to you? Especially
Yes, sir.
measurement techniques, past paper questions, if you go through, when you will do the chapter, you will do the topic, that time in past paper questions, you will have this idea. What about absolute uncertainty? That one will come mainly theoretically. Okay. In practical, you need mostly the percentage uncertainty calculations. Okay. In paper 5, A2, there is absolute uncertainty also there. In from graph you will get the absolute uncertainty. That time in practical, or we can say in alternative practical, whatever we are doing in A2, that's not doing the experiment directly with the instruments, that's similar to alternative to practical. There you will get absolute uncertainty. Okay, now continue this, Asan.
Express the uncertainty in a repeated measurement as half the range
Okay, so this one is giving you
of the repeated readings.
look, one thing uh, I said you here that 0.1 is the smallest value in the stopwatch, right? But when you are taking the average, like you are taking 3 readings or 5 readings, then you are taking the average, that time you will not write here 0.1, rather you will write 0.05, right? If you are taking average of any reading, that time your uncertainty, that means absolute uncertainty, will be half of the original absolute uncertainty. Clear to you? Or half of the accuracy value, accurate value. Clear to you? Hello? Hello? Amena? Asan? Hello, Amena and Asan.
Yes, sir.
Yes, sir.
For the time being, we were absent, right, from the network. So
Yes, sir.
it's clear to you about the last part. Express the uncertainty in repeated measurements as half the range of repeated readings. Did you hear
Yes.
me that time?
I just hear till
I didn't hear
0.5.
you, sir.
Yeah, 0.05. That time we should take it half of the minimum value. Okay. The previous one we took 0.1, right? isn't it?
Yes, sir.
But this time, if you are taking the average, like for measuring time, sometimes you are taking the average of 3 readings or 5 readings. That time you have to take the half of the minimum, value or accurate value or accuracy value. Clear? So
Yes.
that time our time should be 0.05 seconds. With that value, we will take the percentage uncertainty. So till now we will stop here, right? Hello,
Yes, sir.
Yes,
Yes,
because
sir.
sir.
our time for 40 minutes is very close. We have another practical class. Will you continue that one, or today we'll stop here?
Today we can stop here, sir.
Yes,
What
sir.
about Asan?
Sir, yes.